Okay, in the last video, we did some practice problems where y is the quotient of two different functions. And when you have it set up like this, our formula for finding dy dx looks rather cumbersome because you have to have this multiplied by the derivative of this, then you subtract this function multiplied by the derivative of this function here, everything divided by this function squared. So it seems like at first glance maybe a really cumbersome or perhaps even just too complicated to use. But in the last video we used it to solve a couple of problems, and you saw it wasn't such a bad deal after all. So let's look at a couple more problems to get a little bit more experience with this. Suppose we have s is equal to 2t divided by 3t squared plus 1, and we want to solve this for ds dt. So that equals this function times this derivative. So we'll write this down, 3t squared plus 1 times the derivative of this, that's just 2, minus this function here, this one here, times the derivative of this one here, which is going to be 6 times t. So we had this function here times the derivative of this one, minus now this function here times the derivative of this one. Everything divided by this function squared. So it comes out like that, and that's it. The calculus is finished. Now, let's see if there's a little bit of algebra that maybe we can do. Here we have 6t squared plus 2 minus 12t squared. 6 times 2 is 12. Divided by this 3 times t squared plus 1 squared. Or let's see, this would be equal to, looks like minus 6t squared plus 2 divided by 3 times t squared plus 1, the whole quantity, squared. And that's it. We could factor out a minus 2 from here if we wanted to, but that essentially is our answer for ds dt. So, again, we have, this is our problem here. We have this multiplied by this derivative minus this times this derivative divided by that squared. And as soon as we go through those steps right there, the calculus part of the problem is finished. After that, it was just a matter of doing some algebra, and we got the answer finally in this form. So that's it for that problem. Let's try, say we have y equals x plus 1 divided by x minus 1 quantity squared. And now we want to find dy dx. So dy dx will equal, this is raised to a power, so we have to bring the 2 down. So we're going to have 2 times x plus 1 divided by x minus 1 to the 2 minus 1 power, that's 1, or that's just what this is. So typically we don't bother to write that down. And when we do that, though, it's times the derivative of what's inside the parentheses. So it would be times d dx of x plus 1 divided by x minus 1. And then, to do this derivative, we have one function divided by another function, so we have to use our quotient rule to do this part. So let's see. Let's work with this. We have here d dx of x plus 1 divided by x minus 1, and that is equal to, we will have this times the derivative of this, and that's just 1. So we don't even bother to write that down, minus this function here times the derivative of this one, and that's just 1, so don't bother to write it down, divided by x minus 1 squared. And let's see, here we have x minus x, so it looks like the x's cancel out, and negative 1 minus plus 1, that'd be negative 1 plus negative 1, so this would be minus 2 divided by x minus 1 squared. So we know what this is. Now let's go back up to here. dy dx equals 2 times x plus 1 divided by x minus 1, that's this, times this, times minus 2 divided by x minus 1 squared. And this will be minus 4 times x plus 1 divided by x minus 1 cubed. And that's our answer. This gives us minus 4 times x plus 1, and down here we have x minus 1 cubed. So there it is. So again, at first glance it looks horribly complicated or very cumbersome at best, but as you can see, when you start using it for some problems, it's not such a bad deal after all. So try and work some problems with it and see if you can get used to it, and come back and join us for some more videos, and we'll see if we can work some more problems.